Okay, we're going to talk about solving radical equations. So this is kind of what we've been building up to for the last few weeks of class, is taking a bunch of the radical rules that you have learned and using them to solve an equation. Here's an example of a radical equation. So it's got a radical in it, and it's an equation because it has an equal sign. That is the definition of an equation. It's got an equal sign. And solving this would be so much easier if I didn't have a radical in there. If the radical symbol did not exist, boy, this would be way easier. How can I get rid of a radical? Now, specifically, what kind of radical is that? What kind of root is this? That's a square root. How do you get rid of a square root? How do you undo a square root? You do times it by itself. Timesing it by itself is the correct answer, but there's a pretty short way to do that, which is just square it. That's the same thing as timesing it by itself, right? I'm going to square that whole side of the equation. Now, when you square it, what happens is the square root and the squared cancel out, and I'm left with what was inside, 2x minus 3, which is great. But I can't just square the left side to get rid of the radical just because that makes life easier for myself. If I square the left side, I got to square the right. 9 squared, as it turns out, is 81. That is an almost comically easy problem. How do I solve that?
Solve for x.
Yeah, solve for x by, I heard somebody say add 3. That's right. And now? Divide by 2. Great. You guys are so good. So the value of x in this problem is 42. So that was pretty easy. We had a square root. We got rid of it by squaring. Done. It's pretty simple, right? What would you do if you had something besides a square root over there, though? For example, there's my root, 16x minus 3, and then outside the root, minus 4x. So squaring both sides right now is not going to work out for me because if I square this side, I'm going to end up with a distributive property nightmare. Let me just show you. I'm going to pull out a sheet of scratch paper because I don't want to put this in our official class notes. On a sheet of scratch paper, let me show you how bad it would be if I were to square it right now. 16x minus 3 minus 4x, if I were to just square it now. What that means is the square root of 16x minus 3 minus 4x times the square root of 16x minus 3 minus 4x. Now, hopefully what you're thinking is that's disgusting and I don't want to do it, which is correct. But it's even worse than that. Not only is it disgusting and I don't want to do it, but it won't even get rid of the radical because when I distribute, square root 16 minus 3 times square root 16 minus 3 is 16x minus 3. But then root 16x minus 3 times 4x is minus 4x square root 16x minus 3. And then I'll get another one when I do this. So not only is it disgusting and I don't wanna, it doesn't even do the thing that I need to do, which is get rid of the radical. So there's got to be an easier way, and it turns out there is. The easier way is, how about let's just move the 4x over so that the radical is all by itself. That seems like a much smarter idea. I don't know why we didn't do that in the first place. Now squaring it on both sides makes sense. Because if I square the square root of 16x minus 3, what do I get? Just 16x minus 3. I also need to square the right side. What is 4x squared? Yes.
16x.
There we go. Great. Love it. Okay, good. Now what? It's been a long time since we've done one of these. Uh-huh. Yeah, could we factor this? Anytime you end up with a problem that has both x and x squared in it, generally the solution is going to be we need to factor this. So let's, it has to equal 0 for us to be able to solve it by factoring. It's been a long time since we've done this. It's been a long time. Hello, darkness, my old friend. Man, this blue marker, it is the pits. Rest in peace, blue marker. I put that in the marker recycling box, not the trash can. Okay, you remember how to factor this? Yep, is there a greatest common factor? Sure doesn't look like it. Yeesh. Oh, you remember factoring by grouping. What a smart kid. So there's A, there's B, there's C. All right, so A times C, negative 16 times negative 3 is 48. That's A times C. What are two numbers I can multiply together to get 48, but when I add them, I get 16? 8 times 6 is 48, but 8 plus 6 is only 14.
Oh, 16.
Two numbers I can multiply to get 48, but when I add them, I get 16. Yep, 12 and 4. 12 times 4 is 48. 12 plus 4 is 16. Awesome. Okay. I forgot what to do next. I'm lost. There you go. We take the 16 and split it into 12 and 4. Okay. Then we group them. So look at these two. What's the greatest common factor of negative 16x squared plus 12x? 4x, but remember if it starts with a negative, we factor out a negative. So negative 4x, leaving us with? And you will notice, I hope, that this one is already 4x minus 3, which is kind of a giveaway what the greatest common factor of the second pair is going to be. 1, leaving us with 4x minus 3. So the actual factors of this are going to be 4x minus 3 and negative 4x plus 1. And the whole thing equals 0. How do we solve it? Well, if I combine like terms, that's going to involve me multiplying these two things back together, and I'm going to get this again, which does not fill my heart with joy. I'm going to discard that idea because it does not spark joy. I mean, you can. Probably not the best idea.
Is that the answer?
No, we don't know what x is yet. Yeah, I would love to do that, but first, these two things are being multiplied together, and I get 0. What does that tell me about these two things? There we go. You go, girl. Ouch. Ouch. Miss Early 90s catchphrase is in the building. I was alive during the 90s, whippersnapper. I'm allowed to say that stuff.
I was alive in
You are appropriating my culture. You were not alive.
99. My second husband.
Did you just say you were alive in the 90s? Were you born in 99?
Yeah. Really old.
This is embarrassing. You're not a 90s child if you were born in 99. You missed all the good stuff.
I just working it, and I totally forgot everything.
So these are my two answers.
I don't know.
Born in 99. It's awful. So we have two answers to this problem. The answers are 3/4 and 1/4. Okay. So that one was a lot of work, but the reason it was a lot of work is not because of the radicals. The reason it was a lot of work is because of the factoring. Radical itself was still pretty simple. Our goal was get the radical all by itself and then square both sides. That gets rid of the radical. Okay? Unless something crazy happened, like, I don't know, it wasn't a square root. Not that that would ever happen. Except for literally right now.
Do you cube it?
Yeah, we want to cube both sides to get rid of a cubed root, but I don't want to do it right now.
-5.
Yeah, I want to get the root by itself, so I'm going to -5 on both sides. Good. So that's what it looks like after I subtract 5 on both sides. Now I've got the root all by itself. Now would be a great time to cube both sides. So what do we have over on the left? Okay, I said left, but we can start with the right. -8. X plus 1 over here. And now this is like ridiculously easy. X equals -9. So that's how you can handle something that is a cubed root. Yeah, that one wasn't too bad.
Oh, no, not him.
I am going to make it worse. I am going to make it worse because that's how math works. You should know by now how it goes. It gets harder and harder until somebody cries. So, really? Wow. Were we even in this class 2 months ago? You started crying when you signed up for the class before it even really started?
Yep.
As soon as I registered for this class, the tears started. Great. So I am going to make it worse, but not with a cubed root. This is still a square root, and hey, bonus! The square root's already by itself. You're welcome. That doesn't look bad at all. It's a square root, and the square root's already by itself. You know what? I think we're ready to just square both sides. Don't say I never gave you anything. Unfortunately, although the left side is going to turn out great, the right side is going to be, well, the math term that we use is dumpster fire. Because x minus 2 squared means
X squared minus 4.
x minus 2 times x minus 2. Well, partially.
Plus.
X squared minus 2x
Oh.
minus 2x plus 4. So x squared minus 4x plus 4. So one of the things you should realize when you're looking at this problem is that because it has both an x squared and an x in it, what are we going to have to do?
Stuff from the left to the right equal to 0 factor.
Yes, and I really like your idea of moving it from the left to the right instead of the right to the left so that the x squared can stay positive. That's a good idea. So we're going to add the x on both sides. And then we're going to go ahead and subtract 4 on both sides. So on this side, we're going to have 0. And on this side, we'll have x squared. And then negative 4 plus 1 is negative 3. And then plus 4 minus 4 is 0. So this one actually does require factoring, but the factoring is not bad because there aren't two parentheses here. What do we factor? Yeah, just the x, the greatest common factor. So 0 equals, greatest common factor is x. What would that leave me with on the inside? And now we just set each one of these equal to 0, which is pretty easy. I'll do the hard one for you. All right, there we go. You're welcome. What's the other one? That was really not that hard. Yep, x minus 3 equals 0, which is 3. So my answers are 0 and 3. So, yeah, bad, but not like that bad. I may have built that one up a little more than I should have. Wasn't that bad, right? You had to do some distributor property, but you survived. You survived, and we all came out a little better on the other side, right? No, not willing to go that far? Okay. Okay, so what happens if there's two square roots? Yeah, I still want to square to get rid of the radical, but here's the problem. If I square right now, I'm going to have to do distributive property with two different radicals, which is going to do two things that I don't like. It's going to be gross, and it's not going to get rid of the radicals. My process is still the same. Get the radical by itself and square it. The only difference is now this time there's not the radical because there's two of them. So I'm going to get a radical by itself and square both sides. It doesn't matter which one, although I would sort of like to get rid of this one first just because that one's the nastiest. So what I'm going to do is get this by itself by subtracting the square root of 2x on both sides. So that gives me the square root of 2x plus 5 on the left, and on the right, I'm just going to leave it in that order, 3 minus the square root of 2x. Doesn't matter. Okay, so we've got a good news, bad news situation here. I'm ready to square it because I got one of the radicals by itself. So the good news is the left side of this equation, and the bad news is the right side. The left side, when we square it, is so nice. The squared and the square root cancel, and it's 2x plus 5. Ah. The bad news is the right side, because dear sweet Lord of the Dark, what is happening? I now have to do the distributive property with that monstrosity. This is truly a face only a mother could love, and even she's not a huge fan. Ooh. Okay. So we've got some distributive property to do. Well, you have some distributive property to do. I feel like this is a good time for me to take a break. I'm going to have to multiply some radicals in the distributive property. You're going to have to multiply some radicals in the distributive property. But I have faith in you. I bet you can do it. Good luck. I'm waiting. What do I multiply first?
3 times.
Okay, that's a good idea. 3 times. Mm-hmm. Yes. Yeah. Well, I can't multiply those and get 6x because one's inside the radical and one's not, so it's just 3 root 2x. And then here's the exact same thing. Negative root 2x times 3 is going to be another minus 3 root 2x. Seems all right. The last part's not bad. What's the square root of 2x times the square root of 2x? Yeah, 2x, and it's negative times negative, so positive. And the two things in the middle, negative 3 root 2x minus 3 root 2x, are like terms. I can combine those. So I guess, for lack of a better option, let's go ahead and do that. So this has been a lot of work, and what I came up with is really gross. But one of my radicals is gone. I started the problem with 2 radicals. I did a whole bunch of awful stuff, but now I only got 1 radical. I still need to get rid of the 1 radical that I have left. That guy's still got to go. But I'm 1 step closer. I do see something kind of helpful. We've got 2x on both sides. Why don't I subtract 2x on both sides of this? That's handy, because the 2x's are going to cancel out. I'm going to go ahead while I'm at it, subtract 9 from both sides so that I can combine those numbers. Huh?
I hate when you do that.
When I do what?
When you don't do it in steps, it's just all there.
Oh, you'd prefer like
All the way down, just steps, all the way down.
1 step at a time? No. Well, I'm going to tell you the same thing my dad told me when I was 8 years old and told him what I wanted for my birthday. Nobody cares what you want.
I'm the student. I am the one that needs to learn.
Yep. I'll tell you the same thing my dad told me with the day that I turned 18. You're on your own. I'm not helping you with anything ever again. Do I have the radical by itself yet? No. I do not. So, yeah, let's just divide both sides by negative 6. That seems like a great idea. You are so smart. Sometimes. 4/6 reduces to 2/3. It's a negative divided by a negative, so positive. Wow, this is all of a sudden looking pretty doable. Yeah, now I've got the radical all by itself. Let's square both sides. Suddenly I have a positive attitude about this. I know I was a little bit negative before, but I'm suddenly optimistic here. Now, if you're like me, you're going to get this entire problem completely right up until this step where you have to do something simple like divide by 2, and this is where you're going to mess it up. Because I got to do 4/9 divided by 2. What's 4/9 divided by 2, children? If I was multiplying by 2, it'd be 8/9. I'd multiply the numerator by 2. When I'm dividing by 2, you said 2/9. Yeah, 2/9 is great. I was thinking 4/18, but your answer is even better because it's already reduced. Cool? Extremely cool. So one of the primary uses for solving these radical equations, one of the big things we use it for. I gotta get my tool. Now this shape, kids, is called a triangle. And when I put this little mark here, that is a right triangle. And let me go ahead and give you some sides of this triangle. Let's say that this side is 6 meters long, and that this diagonal side is 12 meters long, and I have no idea how big that side is. How could I figure it out? Yeah, your old pal Pythagoras. The namesake of the Pythagorean theorem. Whether or not Pythagoras was actually the one who came up with it is a point of some debate. What is not up for debate is that Pythagoras was a nut job. There was a cult of Pythagoras that thought he was a deity. You know, the power of math. Indistinguishable from magic. Do you remember what the Pythagorean theorem is? That's the one. So what the Pythagorean theorem is saying is that the sum of the squares of any two legs of a right triangle are equal to the square of its hypotenuse. In layman's terms, if you take the two short sides, square them and add them, it should equal the long side squared. So how do we know which side is going to be the long side? Like, I know 12 is bigger than 6, but is it going to be bigger than whatever that is? It's the hypotenuse. Define hypotenuse for me. How do I know where the hypotenuse is? Exactly right. The hypotenuse is always the one that is opposite the 90-degree angle. So this diagonal side here, the one across from 90 degrees, is always going to be the hypotenuse. So if I were going to label this to use the Pythagorean theorem, I might call this my A, and this my B, and this would be the C. A and B don't really matter. If you got A and B mixed up, like if you called 6B and XA, it's not the end of the world. But C has to be the hypotenuse. Okay, so now let's plug it in. So we've got A squared. Our A was 6, so we're going to do 6 squared plus B was X, so we're going to do X squared equals C squared. C was 12, so 12 squared. That's what the Pythagorean theorem looks like after you put some numbers in there. What do we know how to do? Yeah, I guess we know how to like find the numbers, right? 6 squared is 36. And 12 squared is 144. There's something. Yeah, we can subtract 36 on both sides. That seems like a really good idea. So 144 minus 36 is going to be 108. And then what? Well, it's x squared. I would really like for it to just be x. How do I make that happen? How do you get rid of squared? Square root. The square root of x squared is equal to the square root of 108. You square root both sides. Square root and squared cancel each other out. So the square root of x squared is x. What's the square root of 108? No, 10.39 if you put it in the calculator. Don't be lazy. What's the exact answer? 108 is not a perfect square. It's not a perfect square. 10 squared is 100, and 11 squared is 121. So it's somewhere in between 10 and 11, 10 point something. If you do it on the calculator, you can get an estimate like 10.3 or whatever. How do I figure out exactly what it is? What is the highest perfect square that you can divide 108 by? 108 can't be divided by 100. Can it be evenly divided by 4?
Yes.
Can it be evenly divided by 9? Yes. Can it be evenly divided by 16?
Oh, that's right.
No. Can it be evenly divided by 25?
No.
What about 36? Yes. What about, what would the next one be after 36? Next perfect square. 36 was 6 squared. 7 squared is,
49.
can it be divided by 49? No. What's the next perfect square after 49? 64? Can it be evenly divided by 64? And 64 is way too big because 62 64s is over 120, right? So 64, I could probably stop there. What was the biggest one that you said yes to?
36.
36. So square root of 108 is the square root of 36 times the square root of, I believe it was 3, right? 36 times 3 is 108. And the square root of 36 is, so 6 root 3 is the exact answer. So if you were to type square root 108, yeah, if your calculator will do square roots, like simplify square roots for you, you can just go straight to that answer, which is nice. If your calculator won't, you have to do the factors like this. And I assume some of you are going to start shopping for a new calculator right now if yours doesn't do square roots. Walmart. Oh yeah? Amazon.
So how did you do that with your calculator?
I just did, so it was 108, I just did square root.
But it won't answer like it does. Oh, you got the same.
What an exciting time to be alive.
And it'll convert it. Okay, thanks. I've been trying to figure it out.
Yep, I'm getting it.
It was only like $20 at Walmart. Like
Does-
in the office section.
Does anybody have any questions about how to solve these equations?